Hi, welcome to everyone's favourite segment, Mailbag. Yes, it's back. Yes, we've got a build up on the bench, so let's get to it. So if you want to send something in, send it to mail. It's got to have Mailbag on it. PO Box 7949, Norwest, New South Wales 2153, Australia, not Austria. So thank you very much, Alon Gendel from Israel. Hi to all my Israeli viewers. Do have quite a few from Israel, actually. So this is the biggest one. So I lost count of chronological order. They just get mixed up on the mailbag. So let's crack into this one. How do I... that's actually the bottom. I've got to get into the back. Tongue at the right angle matters. It's got a handle. Something after my own heart. No, it's not test gear. Hang on. Whoa, this is heavy. Oh, we got a bonus attachment. Look at this bad boy. There's no weight in that. There's no weight. Can't be any good. There's no weight in it. But it's the Panasonic Super VHS, none of that regular VHS rubbish. Camcorder. Wow. It's a DP200 for those playing along at home. Hands up if you used one of these bad boys back in the day. Yeah, I was going to say, why is it like that? It's because it's got to swing out like that and, yeah, get your eye up there and... Yeah, none of that LCD screen rubbish. Thank you very much. Fantastic. It's got XLR. Oh, it's a pro. Hi Dave, love your channel. 2 items for your consideration. Panasonic Super VHS DP200. None of that VHS. Already said that. Am I that predictable? Really? It was used for community channel field reporting in the early 1990s. Sort of works, but needs new belts. Belts. Remember those? 5-minute teardown. Yeah, it's going to have to be a separate video. This is, it's not 5-minute mailbag teardown. Sorry. And, oh, look at this, a Casio G-SHOCK Mudmaster. Wow. I don't like big watches like this. Here we go. Check it out. Look at that bad boy. Look at that. Wow. The Mudmaster. I mean, that's a serious bit of kit. Yeah, for my mud runs and stuff. I got my mud run t-shirt. I forgot to change my t-shirt. I got my Tough Mudder t-shirt on. Yeah, should have changed that doll. But, oh, nice. That's a nice teardown. The second hand occasionally becomes stuck. Oh, it's just misalignment or something, is it? And Alon's got his own website, linked in down below. It's microvax2.org. Jeez, I wonder what that's about. Okay, we'll just take a brief look at this bad boy because, well, we don't have time to tear it down. It's the DP200 Super VHS, none of that regular VHS rubbish. If you don't know, you might be able to see it. There it is, 625. Wow, that's, yeah, 625 pixels across. But because it's Super VHS instead of regular VHS, has a whopping 420 lines of resolution as opposed to 240 on regular VHS. And Super VHS also increases the luminance bandwidth, so technically you get like a better quality picture and stuff. But anyway, it says push. I don't know, it must be powered open or something. I'm not sure what the deal is. And as I said, XLR input down here. I assume that's for an external mic. And there's just like a dodgy, unlabeled knob down here. So is that like some like aftermarket hack or something like that? Maybe. It's made in Japan. All the best stuff's made in Japan. Absolutely fantastic. It's got a character generator, which is really interesting. That's like, you know, pro-level stuff so that you can insert characters over, like, you know, text over the image. That would have been really state-of-the-art back in the day, but anyway. Nameplate for those playing along at home, and we've got a thread mount and everything. And these are designed like really quite ergonomically. This is designed to sit on your shoulder, of course, and then you've got the viewfinder here, which is none of that LCD rubbish. That's got a CRT in there. It's got a tally light as well on the front, which allows your subject to see that the person being interviewed, whatever, to see that the tape is a roll-in. And yeah, it's got an eyepiece, and there'll be a CRT in here. We've torn these down before. They're really quite cool, these little micro CRTs. They're very nice. Geez, that's a bit dusty. So yeah, the whole idea is that you have to put your eye right up to there. So you've got one eye on the shot, one eye on the viewfinder. If anyone used to be, like, use these cameras back in the day, like they still do, like you still get the shoulder mount run and gun cameras. I've done a video on that on the second channel. But anyway, and then your hand, of course, goes in here like this, and this is ergonomically designed. There's your start stop, and there's your electronic zoom there. They've also got a slider on here as well, so presumably that's motor driven, and you should be able to see. Can you see the lens inside there change? Yeah, there we go. Look at that. Beautiful. Don't know what all the gunk is though. No idea. Anyway, that's got a 12 times optical zoom, none of that digital zoom rubbish, but it's pretty feature-packed. I mean, it's got low light, focus, you can open and close the iris, you can white balance adjust, you can switch between iris and shutter control, and you can have auto or manual or portrait modes for those, and you can fade in, you can get on-screen display, so you can put the date time overlay and stuff like that, which is, of course, very common back in the days. Geez, nobody has that, and your cameras don't. Do cameras even still have a date time overlay feature? I don't know. Anyway, we can do some sort of search capability and stuff like that. And on the top here, it had some sort of like a warning sticker, I guess. Removal, you know, don't dig around with this, because this is where you set the date time and the counter and stuff like that. So you can switch that off or on. And there's our power button on the top. Then we've got a cold shoe mount, of course, none of that hot shoe rubbish, and oh, the mic has got wide, tele, and zoom select as well, and it's got rubber baby buggy bumper on there, so that'll take out some of the vibration, but none of that image stabilization rubbish in this. But if that microphone's not good enough, external mic, no worries. So, like, I assume that the XLR, I don't know, I haven't read the manual, I assume the XLR down there's for the mic, but all that's unlabeled. And then on the back, if you want to use it as a VCR, you want to play it back, there's your controls, no wuckers. And there's your battery eject. Your battery goes down in there. It's got a big spring down in there and a couple of contacts. Your tape eject button. Then we've got composite video out and also an RF, like DC output that presumably powers an external, like RF interface. Oh, it goes in there. Okay, so it's like a little physical attachment that goes on the back, and these are two pins that provide power through to your RF modulator, and then you can plug it directly into a TV. Anyway, audio out, and we've got higher quality S-video out as well, and edit, presumably there's some sort of edit box facility or something like that. Internal speaker, you can have hi-fi or normal, and a weird-ass DC jack. The amorphous Pro Head sounds impressive. So anyway, leave it in the comments down below if you used one of these bad boys, and what did you use it for. So yeah, thanks for sending that in. Obviously has to be a separate teardown video, because there's an hour's worth of teardown material inside this thing. So fascinating. I've also got like another big camcorder like this to tear down that came in like that big plastic carry case and everything like that. Still got that someone sent in the mailbag. So, you know, keep pestering me if you want to see the teardown. Thanks. That's brilliant. Look at it. Oh, just completely went the way of the dodo. Unbelievable. And today's home lab comes from Andrew Tayman. Thank you very much. Doesn't say where he's from. It's just, here it is. It's your basic, regular looking lab. We've just got a, like, you know, fairly long bench. Looks like at least two of them could extend out further. One big length of ESD mat. That's probably, is that... they're usually either like 600 or 900 mil deep, unless it's like a custom depth or something like that. But they're your typical, like a short one will be like 600 mil, a long one like I've got 900 mil, something like that. So we've got ourselves a fluke down here. We've got ourselves one of those inspection microscopes. It's one of those, I can't remember their brand. They keep sending me, I've got like 5 of them I haven't reviewed or something. They just keep piling on. Multiple sucks of the salve. Anyway, yeah, we've got our precision screwdriver set. Nice. JBC, is that a... Yeah, that looks like I haven't seen that particular model before, but there you go. Got the obligatory mug. I don't know what that is. I can't see... Maybe it's a special purpose bit of measurement kit. It's like... be some sort of, like, you know, power, custom power measurement doodad or something. Anyway, we've got the Roden Schwartz RTB 2000 by the looks of it. A lot of people picked up that bargain when they released that. We've got, two high-end 6.5, 7.5 digit meters here, the Keithley and the Keysight. We've got another Keithley bit of kit over here. What is that one? It's a power supply. That looks like one of those precision power supplies. They often use those in like providing power for like mobile phones under production tests and stuff like that. And they can provide like really fast pulse loads, and they can, you know, simulate all sorts of like battery stuff and things like that. Those things aren't cheap. They're very specialized bits of kit. So if you can score one of those on eBay, you're doing well. They hold their prices. Looks like we've got the Rigol electronic load over here. And we've got the Rigol 832 power supply, isn't it? And cheap-ass hot air gun here. We've got another, that's a solder sucker by the looks of it. Yeah, solder gun, solder sucker. We've got, looks like the components up here in little tray box things, microcontrollers, resistors and all sorts of stuff, IDC connectors, LEDs, headers, blah, 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 all sorts of stuff. Everything nicely on the pegboards in the background. Beautiful. What else we got? Yeah, there's the JBC down there. So it's interesting getting the iron up onto the top up there, and actually only having your iron down here so you can free up your bench space. That's a good idea. And then we've got the open top trays here. I've done a video building open top trays. I really like them because you can just pull them out and the stuff's just there. You don't have to take lids off and things like that, which is really annoying. So I'm trying to partially transition over to those and got more stuff up here. Looks like reels of stuff and things like that. Yeah, SMD reels and, you know, stuff like that. Because often, you know, you do a short production run, you got some, you know, reels and stuff left over, and yeah, you want to keep them. So there you go. That is a very nice basic layer. Well, it's not basic because there's some high-end and specialized bits of kit here for various things that he works on. So there you go. I don't know what's being worked on down there, but yeah, it's obviously, you know, it's your basic lab, and then you equip it with some like specialized stuff. And, you know, usually like a basic lab's not going to have two, you know, 6 or 7.5 digit meters in here, you know. So once you sort of step up to that sort of level, like you need a reason to do that. And it looks like, yeah, a precision power supply or some such, and something else over here. If you know what that is, leave it in the comments down below. But neat. And here is the G-SHOCK Mudmaster. Look at this beast. That is just insanely thick. Wow. That's incredible. And look at all the protrusions for the buttons and everything else. Shock resistor. I mean, this would be like, yeah, this would survive anything. Incredible. So it looks like it's got an altimeter. That's the button that switches that on. This button on the front here, you might think this is some sort of sensor. Nope. It seems to match these. These seem to be the big buttons. That's the light button, so it doesn't seem to do anything. It's now flashing charge, charge, charge. But anyway, barometric pressure sensor and temperature. So is that barometric pressure sensor there, and that's your temperature sensor there, perhaps? And of course, it's got the really old school, like different time zones, London, Paris, and all that around the side. Yeah. Does anyone have those anymore? Like, do you find it, like, you know, if you're traveling and stuff like that, like, I just think it's messy on an analog watch. Not really a fan of the combination digital analog watches, but anyway, if you want to see what I'm wearing at the moment, I've got a Citizen Eco Drive, so you can see the size difference there. This is a ridiculously large case, and this is quite small and thin. And if you look at the look at the differences in those, I mean, that's just nuts. Anyway, this thing on my wrist would look insane. There it is on my wrist, because I don't have a big wrist, so I suit the like the slimmer form factor watches and stuff like that. So yeah, that's just, oh man, no way. Like, there's no way I'm gonna wear that. That's just crazy. It'd just get in the way. I mean, if you're doing like a mud obstacle course, or you're doing any sort of like mountaineering, or I'm going canyoning or something, like, that's just like, no. No, 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 no. Okay, let's have a look inside this thing. It looks like some sort of resin case, something like that. So we've got our self-tappers into resin, which is kind of par for the course, but lifted off, we'll expect to see an O-ring, of course. nothing's waterproof without an O-ring, and there it is, and nothing's waterproof without an O-ring and grease. So there's no point having an O-ring if you don't grease it up. Anyway, piezo transducer on the back. Not sure what that is. Oh, that's that just like a little, that's a pressure plate. Yeah, I think that's just a little pressure thing to put pressure onto the battery to keep it in there, perhaps. But anyway, there's some tiny little contacts down in there for our battery, and I like that. I like the red rubber sheet. Usually they use like a Mylar type sheet or something like that, but that's red rubber baby buggy bumpers. And in typical digital watch construction, it all seems to, that's going to all pop out in a module. Anyway, as far as the G-SHOCK technology, which makes it all shockproof and everything else, that's got to be these little red, yep, they feel like rubber, yep, those little rubber inserts that actually keep the internal module in there from, you know, banging against the sides of the case like this. So the case can take a physical impact on here, and then that's going to be attenuated by the red little compliant mounts like that. And the buttons are somehow like physically isolated. I'm not exactly sure. That one's a bit how you doing. And as I said, that one doesn't, light one doesn't seem to push. Some of the others do. Yeah, the buttons are really how you doing on this. I don't like them at all. I can't really press them properly. But yeah, it looks like there's probably another mount on the face side as well, because they're obviously, this is why they're using rubber here, because that gives it some compliant mount from the back case like this, and then it would almost certainly, you wouldn't go to that sort of effort doing it on the edges plus the back and then not do it on the front. So if we can get that module out, which is probably going to be tricky, there is probably an art to it, but yeah, I reckon we'll find another compliant mount on the top. I managed to get the retainer plate out. I'll spare you the gory details of that. Anyway, we have our battery holder like this, and there you go. That's its own little, little springs in there. So that's its own little assembly like that, which then makes contact down onto the main PCB down in here. So there you go. You can see a few inductories down there, and you know, it's your typical digital watch. There's not a huge amount in it. It's going to have a blob somewhere on the other side. The buttons in there do seem to have the same castellated edge on the PCB like that, and then making and then the pin comes through, because I've physically pushed that one out and you can see it come in and make contact there. I really don't like those buttons at all. Well, there you go. I got it out, and that's all the one assembly like that. Which is really nice, and that's typically what you'll get inside any modern digital watch, or sort of, you know, even though this is a combo digital analog watch, you'll get the completed assembly like that. It allows them to design and test those. Notice all the test points on the back there for all the Better Nails production testing stuff, and then it goes within an outer case like that, and then it usually has some sort of battery assembly, and then sort of some complex retainer mechanism to hold it all in place to make sure it doesn't fall out. But as I said, I expected to see a compliant mount on that side, but there's not. That grey one down there, that's plastic, so that's not, it's not the red rubber that we saw on the other side. So I guess they couldn't do that. That's one of the rubber inserts that was inside there. So that's interesting. But anyway, there's our temperature sensor by the looks of it. That's a little flat flex connector there, and that, yeah, there we go, just pulled out from the connector in there. So that'd be a bugger to get together, wouldn't it? I wouldn't like to be working at the G-SHOCK factory, that's for sure. Anyway, these buttons, you might be able to see there's an additional contact there. Of course, that one button's not enough to make electrical contact, so they have another one up there, which then combined, it forms a switch on the side with the castellated edges. But look at the thickness, or lack thereof, of that PCB. Wow, what's that? Anyway, for those who wanted to know the total watch thickness, there you go, that is a thick-ass watch. As opposed to my nice little slimline Eco Drive here, look at that. Oh, a width of a fag paper over 9. And the thing is, with the PCB at this sort of thickness, every PCB becomes a flex PCB. And I've actually used that aspect in designs before. We've actually, I specified, which is not actually finished PCB, but a PCB pre-preg. I specified them to use really thin pre-preg material, like, you know, 0.1 millimeters, and you can get boards like that sort of thickness, and they're just like, they act as flex PCBs. It's incredible. 0.3, yeah, about 0.3 millimeter PCB. So these really aren't designed to be repaired. I've already broken something off there. What is that? Oh, there you go. There's our crystal. It's a crystal in a little plastic holder. Yeah, usually they just have those soldered on the back of the board, but this actually, there you go. It's just embedded down in there. That's neat. But anyway, you've got to remember, this is a mechanical watch as well, so it's got to have all this stuff inside there. And yeah, that's pretty impressive, but it looks like it might have heat stakes or something holding it in place. There you go, managed to get it apart. There's our PCB there, and yeah, it makes press fit contacts down here to the little tiny itty bitty springs in there, which go down to our coils for our mechanical mechanism, which is all in there. Then, of course, we've got our, what looks like a OLED, what looked like on the front, to be an OLED display. And there's all our contacts down on the main PCB. Of course, that'll be a custom blob. There it is. There's the main chippy down there. It's got a protective film. Slice that off. Yeah, there we go. There we go. There's our bare die. Or getting closer to it anyway. So anyway, that is fascinating. Thank you very much, Elon, for sending in the camcorder and this G-SHOCK watch. I always wanted to take a look inside one of these, and yeah, it's rather fascinating. And it's just not the mechanical and packaging design of something like this, which is like absolutely critical. Like, you can't just have a couple of electronics designers designing a watch like this. You've got to have like a really advanced team of, you know, to try and get all of this manufactured at a low enough cost, manufactured with reliability, manufactured to meet all of the, in this case, the physical shock and other performance requirements and stuff like that. And also, you know, just thermal design, just isolating the temperature. I presume that's the temperature sensor, or is that barometric? That one, you know, that sensor over there. But anyway, like, I've actually designed watches and I've put a temperature sensor in a watch, and it's not easy to actually isolate from the heat of your wrist. So, you know, that's something that is, you know, you really have to take into account, and it is rather annoying. So in that case, maybe that over there is our temperature sensor, perhaps. There you go, I just took off the outer plate for that one, and yep, I reckon that is our barometric pressure sensor. Actually, there you go. Check out that. Took the plate off. It's got lots of gunk in there. Wow, that's terrible, Muriel. Ah, it's just filled with crud. Wow. Okay, what we're actually looking at there is a re-enterable silicon gel that allows the pressure to come through, but no moisture. So there you go. So all the particles, someone's had far too much fun with this watch, and it's just all collected in there, but it still would have worked. Still would have worked a treat. So, yep. Ugh. Ugh. And our temperature sensor looks like it just screws out. Oh, look at that. Neat. Wow. Didn't expect that. And so I can't get that apart any further, so I'm going to assume that at the end of that is a thermocouple, and they've just like isolated that from the case, basically, using that method to isolate it from the case, and also you know, any radiation coming directly off your skin as well. So that's an interesting way to do it. I don't know. Did anyone has got one of these and they've had how good is the temperature sensor in it when you're actually wearing the thing? So yeah, it's an impressive amount of technology that goes into all this, not to mention, like, you know, low power ASIC design for getting, you know, I don't know how long the battery life in this thing is. If you do, leave it in the comments, but, you know, it's got to be pretty decent. And these things aren't cheap. They do sell these for, you know, many hundreds of dollars, I believe. They're, you know, worth a pretty penny, so they're not your traditional, you know, $5 or $10 throwaway watch, but yeah, impressive amount of tech that goes into just a Mudmaster watch. Thanks for sending that one in. Brilliant. Should at least have my own merch on. Yes, you can still get this at my Teespring store, linked in down below. Anyway, hi to all my viewers in Germany. Thank you very much. AK Modul Bus computer. Gee, I wonder what's inside here. May not be a Modul Bus computer, but all right, we have a note. We have another note, or is that instructions? Oh, look at this. Oh, we've got some oldie stuff. Oh, look at that. That is a homemade decade resistance box. Isn't that sweet as? Wow. It's not your usual sorry, LCR box. All I saw was the resistance knob. I was going to say, geez, that's not many decades, but it's an LCR box. Wow, homemade jobby. So I assume like it's a kit or something like that. Sweet. Bonus, here's something you don't see every day. It's a development board, a breadboard development board that supports tubes. Yes, they are tube sockets on the top. And we got some. That's great. For all you, hey, if you want to develop with tubes, this would be very handy. Now, I've done a video on building your own decade resistance box before, and it's something you should have in your lab. This goes one further, as well as you can get decade capacitance boxes, decade inductance boxes, but this one is an RLC box that tries to do all three in one, as well as having fixed value resistors here like this. So, you know, you don't have like a major range, but, you know, it's good enough for just experimenting and stuff like that. But you also have verniers up here, 10-turn verniers, very nice, and you can actually put R and C in, like you can isolate the resistance like that. You can put R's and C's in parallel and R's and C's in series as well, so that's very handy. The capacitance is, rather than a decade type thing, it's got all your common values, but two separate inner and outer ranges, high and low like that. So high would be the larger values, would it? But look, this inner ring goes from 15 puff around to 6.8 puff. So it's like, so the inner ring goes like low to like really high. But anyway, it's obvious high obviously means the higher value of that. And you can put the inductors and capacitors in parallel as well. Anyway, it's open source hardware, so you can download the Eagle files for it, so you can make your own. This one's 269 euros, so it's pretty pricey if you want to buy the build-up kit. It's obviously designed for educational you know, labs and things like that, you know, students experimenting with things, hence why series and parallel and, you know, stuff like that. Really quite nice. I really like the binding posts on it. That's really quite neat. And the box is a bit how you doing though. Like yeah, it's just a bit too big for its own good there. I think. Anyway, let's pop it open. Oh well, hello! Isn't that beautiful? Wow, I really like that. Look at the beautiful wafer switches they've got down here, and I love how they've like manufactured the board to then just solder directly in there, and they've got the individual little, this is a really nice, elegant design. I really like it. So the PCB, like they've extended the routing out there with the contact. So what you do, you might think, well, how do you get the board in there? Well, you shove it between the pins like this, and then, so you lower it between the pins like this, all these little protrusions, and then you rotate it just like that until it's in the middle of the pins, and then you solder it on there. That's just like, that's really, oh, actually, you could put it from the other side. Yeah, no, I stand corrected. You can actually just do it from the front side. There's no need to put it through there and actually rotate it. I was getting all fancy-pantsy there. There's just no need to do that. But there you go. They've obviously got room for like surface mount parts around the edge here. So obviously, yeah, they got them on the other side under there like that. So I don't know why they got top and bottom. This is the deluxe version. There is a standard version, not sure of the difference, but anyway, so there are all our resistors. They're just like standard, like a 1206 1% tolerance. There's nothing, you know, particularly fancy. There's the vernier for those playing along at home, made in Mexico. Hi to all my Mexican viewers. And the capacitor board. Isn't that very nice? There's going to be some surface mount ones on the bottom. Absolute no, there's actually 2 layers of boards down in there like that. And there's your surface mount inductors down there. There's a lot of work that goes into building this. So, you know, but as I said, like, you can actually build this yourself. You can download all of the files and things like that. So it'd be nice if you could engineer this to be like smaller. Like, my first thought when I got this is, geez, this is a really big box. You know, why does it have to be so deep? Well, you know, that's why. There's a lot of depth in there for the caps and the inductors and other stuff like that, but the switches as well, you know. So if it could be engineered in like a lower form factor solution, that'd be very nice. But geez, isn't that like, that's really nice. That's one of the nicest implementations of an RLC box, just from a physical construction point of view that I've seen. I really like that approach. Anyway, it turns out Roger Leifert, thank you very much, has he started Kanka Labs. Anyway, it's got a YouTube channel, so I will link that in down below. So yes, it's in the mailbag. Everything that's sent in makes it onto the mailbag. Yes, they do sell worldwide, and there's the online shop linked in down below as well. And we've got the vacuum tube kit here. Oh, by the way, he's up to 10,000 subs. Absolutely fantastic. So yeah, give him a subscribe. I'll link the YouTube channel down below. But anyway, yeah, we've not only got that, but we've also got this. This is the RT100 valve experimenters kit. Modul Bus. I'm not sure how you actually pronounce that, but this is really nice. We've got the screw terminals over here. We've got various jacks, because of course one of the things you want to do with valves is you want to design like audio stuff and things like that. So you want your power, and you want your audio in and out. And yeah, it looks like we've got a big pot over here, and then we've got a couple of other pots over here, and all of this, all the pins for the valve sockets here, various different types. I don't know my particular valve socket types, is not my thing, but anyway, yeah, and then you've got a basic breadboard to have a play around with it, and all come to standard headers that you can just use standard solid jumper wire to transfer over to the breadboard. And it comes with a kit. This is a 106 euros kit, and it comes with various valves, tubes, and various parts you can have an experiment with. So that's quite neat. Anyway, thanks for sending those in. I'll link them in down below if you're interested. They're a nice bit of kit. Not sure if this one's a mailbag, because it doesn't have mailbag on it. Anyway, it was sent to my old address. It wasn't sent to my PO box. It was sent directly to the office here. I guess we'll find out if it's something I've ordered or not, or whether or not it's something a company has sent in. No, it's a, yeah, they've sent this in. It's another Miniware product. It's a preheater. Geez, when they say mini, they really mean mini. That is tiny. That is tiny. Look at it. It's the tiniest preheater I've ever seen. That's fantastic. Oh, it just came out. Oh, that's rather nice, actually. But that's all, you know, like, it's not designed for a whole board, unless you're designing a watch PCB or something like that. Then you wouldn't really need a preheater, because there's no thermal mass in something like that. And this is like for getting under BGAs and stuff like that. So yeah, that's like, it's practically exactly what you want, just for like single, like, you know, isolated component heating, because you don't want to heat up your whole board just to get one part off. You only want to heat up just under the component you're trying to get off. In this case, you know, square form factor. It's obviously designed for like BGAs and stuff. Okay, this is designed by eDesign, Miniware. You'll know those from, of course, the famous TS100 and TS80 soldering irons, which I've done videos on. This is the MHP30, and it's got a little temperature display. It's a preheater you can stick your board under. Anyway, really quite nice. It's a retail, get it on AliExpress for about 85 Yankee bucks. Rubber off the top there. There you go. It's like a ceramic plate on top, and that actually pops off. That's really quite nice. I like the interconnect system there. That's really neat. So is that to light it up? I think that's a... Is that a LED, is it? And then there's a light pipe. Yeah, I think it's got a wanky light to light it up. And a little display. There we go. Ooh. So it comes supplied with the really nice, lightweight, flexible silicone USB-C cable that is supplied with the TS80. So it looks like the same one, supplied with the TX80 soldering iron. And we get a dodgy adapter here. Let's have a look. Yeah, it's the USB power delivery one. I think did we get that with the TS80? But anyway, a weird-ass plug on it. And it's like completely not labelled, like there's nothing on it. I've actually never, I don't think I've ever seen a plug pack that like has absolutely no labeling. Like usually there's some bogus markings or something, but geez, I don't know. Anyway, yeah, that is USB power delivery, and you get a little manual. This appliance can be used by children aged from 8 years and above. Okay. Yeah, my preheater needs a firmware update. Great. Specifications 100 to 350 degrees Celsius. It's got various preset temperatures, 60 watts output power max, and yeah, it's of course it uses the US 20 volt USB power delivery. Heat-in part. I love that. Well, it's accurate. Stainless steel heat insulation bracket, controller, OLED screen, and Bob's your uncle. So, you know, it's like it's really incredibly simple, but I like the way that they've engineered that. That is just, you know, it's perfect. Doesn't take up any space on your bench at all. You could store that anywhere. Of course, you know, like the plug pack's bloody bigger than the thing. But yeah, that is quite nice and does exactly what you want. Of course, like the hard part is often like getting your board. Like you've got to have like a stand to get your board, you know, one of those helping hand things or some other frame type system to get your board on top. And then once you've got your board raised up, you can just sit this under there like that, you know, at a little minimum distance away from the board that you're trying to heat up, and it should work a treat. And just as a reference, oh, the PCB, oh, that's a coincidence. That's a coincidence, isn't it? The PCBite, although this is the new one, I think I've got another one which is slightly higher than that, but that looks bang on. No, it's slightly under, so you would have to, yeah, the board, yep. So if you used your PCBites, I'm sticking to it. I'm not going to call it PCBite. It's PCBite. And yeah, so you might have to just raise these up a little bit more. And yep, there's my older one. That one's higher, so I'd use that. That'd work a treat. But then you'd have to raise this up a little bit to get to your board, but that's easier than trying to raise all four of those. Okay, I've powered it up, and yeah, you might recognize the interface. So yeah, the buttons are on the back. So there we go. Here's our temperature. Let's just go for 220, shall we? It's got a sleep timer. Anyway, so let's give that a burn. Oh, it started. Oh, I must have accidentally touched it. I was going to say, there we go. It's heating up. It's heating up. You don't expect it to be quick. This is not, you know, doesn't need to be soldering iron quick. So however long it takes, it takes. No wuckers. I like how it's got a little timer on there for how long it's been on. That's kind of nice. Can you like set... It'd be nice if it had like you could like set a timer when you're like just put it under and started, but I guess, you know, like usually you just put this under your board and then you turn it on, so it's the amount of time, but you know, ultimately you want to know, I guess, the amount of time it stays at that temperature, so it's hard to tell unless you've got a temperature monitor on your actual PCB. So of course, even if you've got this directly touching the bottom of your board, then you don't know what the board's actually at because the thermal coupling is going to be meh. Anyway, let me get the old thermal camera out and see if we can measure it. There we go. It did. It is set to 220. It did like it's overshot a little bit. No wuckers. And it's going back down kind of, yeah, slowly. And there you have it. 225. That's good enough for Australia. No worries. So... yeah, that seems to regulate fairly well. And yeah, I won't experiment in this mailbag video with doing a preheater stuff. You've seen me use preheaters before, and they work. They're a known technology, and it's all in the art of for what particular device that you're using, what particular board density and material, and the amount of embedded copper in there. And there's all sorts of what type of solder you're using, all sorts of stuff which goes into the complexities of like desoldering BGAs and things like that. But this is just really cute and handy. I really like it. I think it's very well worth having in your kit. Because I've got like a giant preheater, which you see me use to do all sorts of stuff, and it's absolutely enormous. Takes up so much room. It's great for heating up an entire board, but usually that's not what you want. You just want to heat up like one part, and that's it. And something like this, absolutely tiny, does that. And that's not getting really, it's getting a little bit warm, but nothing hot to the touch. And that works really well, and I like the way that they've implemented the contacts and everything else. And it's probably, like, I can't imagine you needing anything really bigger than that. Like, there are BGAs that are, I've used BGAs that are physically bigger than this, but not by a lot. It'd still work as a preheater. So, yeah, I like it. It's really cute. Check it out. Hi to all my viewers from Deutschland again. Thank you very much, Thomas Widmeyer. Butchering that one. But anyway, this one sounds intriguing. It, spoiler alert, historic electronic components. Not just vintage, but historic. So I didn't want to be like, I don't know, was it used on like the Apollo moon landings or something? The Snapistor, a new way to trim your circuits. Oh, classic, the Snapistor. You snap it off. I presume what you get your pliers, is it like serrated and your pliers, or you trim it? Because you got to snap. Like if it's a Snapistor, you have to snap it. So I don't see any score marks on there. Oh wow, in original packaging, fantastic. Yeah, you trim the sections by breaking them off with the supplied pliers. This is not going to end well. The Snapistor. This is just fantastic. Thank you, Thomas. He said he tried to snap these off and it wasn't really that reliable. Wonder how many you get in your kit. You want to get a decent amount in your kit. Jeez. So we don't have anything else on there. Let's have a look to see what you get in the Snapistor kit. Like, who actually does this? I'm not entirely sure. Oh, hang on. There's still nothing that indicates who manufactures this at all. Hang on. Oh, geez. Oh, this is all... Oh, look at this. Look at this. Wow. Finland. Hi to all my Finnish viewers. Trimming a Snapistor. Helsinki. Can anyone date this? Please leave it, or if you've used these, please leave it in the comments down below. Snapistor is trimmed by snapping pieces off the substrate. Some comments on snapping and handling. I've used notch pliers like those in the kit to ensure one piece is snapped off at a time. Ordinary pliers will also do, but you can improve them by grinding a transverse notch across one of the jaws. Oh, wow. That dates it, doesn't it? Look at those gigantic axial resistors, and yep, and your Snapistor, just mount it vertically and then just snap it off the value you need to trim your circuit. Oh, it's just, this is gold. Oh, this is how to modify your pliers. Do we actually get the modified pliers? Yes, look at that. We actually get the modified pliers, the special Snapistor pliers. Oh, this is gold. Proper grip of the pliers before snapping. Pliers vertically, properly placed on the other side of the Snapistor. What? Off to one side? Like the... Oh, really? You don't put it on top and you don't hold it? A gentle squeeze of the pliers. Oh, we'll break this right along the scrib line. Okay, so we'll have a look. Final resistor trimmed. So you trim one at a time until you've got the value that you want. It's a new and different trimmer component. Before starting your experiments with it, we suggest you read some essential facts. The Snapistor is a thick film resistor network on a ceramic substrate. Prescribed lines on the backside of the substrate divided into 10 parts. These parts can easily be snapped off one by one. Each snap is increasing the resistance of the Snapistor by 20%. Right, so they've got them all in parallel, and, well, you can see that. You can see them physically all in parallel and snapping off one at the top, and of course the length means that they've got different values, and snapping off the one at the top, it looks like increasing the resistance by 20%, giving a 5-fold increase in resistance when all 9 parts are broken off. Best use when the cost of cermet trimmers is too high. Yeah, those pesky cermet trimmers, they're expensive. Does it actually give you a temp co? of these bad boys. Initial value, TCR, 100 ppm. There you go. Not exactly going to set the world on fire, is it? For a ceramic substrate? Reliability with thick film technology. You can set the gain of a transistor. I love it. The designer's Snapistor kit. Initial resistant. Right, so we've got like the whole... So you get the whole kit. So, anyway, this is groovy. I love this.
Groovy, baby.
So check this out. Look at this. Oh, there we go. There's one that... Tom has snapped off. Brilliant. So, yeah, it looks like we have a whole kit of these, like 10K to 52K. Oh, no, yeah, they're all 10. Yeah, they're all 10K to 52K. We've got 1K to 5K too. And we've got... Oh, why are those ones green? They've got like a mask on them. That's 100 ohms. So they're actually a different physical type than all the rest of them. 47K to 240K. Neat. It's terrific, isn't it? There is the Snapistor. Oh, this is fantastic. Why didn't this catch on? And there's the other one with the solder mask there. So, oh yeah, you can really see the score lines on the back of that. Can't really see it on the others, so I reckon those green ones. Oh no, if you hold it maybe at the right angle, you might be able to get the light at the right angle, you might be able to see some score lines, but yeah, I think they've improved the design in this model here. Right, so here we go. I'm going to try and snap this side. It shows to one side, doesn't it? Oh, that came off really nicely, actually. Wow. That's really groovy. Do it again. Yeah, Thomas said he had problems. I had no problems whatsoever snapping those. No worries. All right, so let's just measure this one before. 105 ohms, there you go. Let's get in there with our special pliers and once again, to the side a bit. Yeah, that snaps off beautifully. Like a bought one. What does it measure now? 125. Nice. Thank you, Thomas, for sending that in. That is absolute classic. Hands up if you knew about these things. Did you use them back in the day? When did they first come out? How long did they last? Did they ever make it out of Finland? Was it, I don't know, the Snapistor? Beautiful. Uh-oh, it's from AliExpress. And it's come in the black wrapped plastic like this. Yeah, so straight from the Shenzhen market. Oh God. Oh no. Oh well, no, it wasn't quite. Oh yeah. No, we had one of these. Oh geez, didn't we? I'm sure we had one of these just a little bit ago. We had like, is it almost identical one? Yeah, I don't think it's the same one though. So, oh, geez, that's crusty. Oh, makes your skin crawl. Terrible, Muriel. But okay, quick. Yeah, 1 minute teardown. Ugh. Do I have to? This is just like, oh, really? Oh God, that's the worst case clip I've ever seen. Ugh, it just, no. I just hate everything about this. Anyway, some people are fans of the form factor of these kind of meters, but this one does actually have non-contact voltage detection. Wow, fancy pantsy. And then you open it up and it's actually not too bad at all, I guess. They've got a ceramic fuse in here. They've got a PTC. It doesn't look like there's a MOV unless it's on the other side. But anyway, nice attention. Like the battery compartment's integral with the case like this. They've attention to detail with the silicon down there. Don't necessarily like the the lack of strain relief on that. Well, there's some kind of going around the bend there, but you know, not terrific. But it might do an okay job. Anyway, there's your non-contact detector over there on that side. But you know, we've been blobbed, and it's got metal threaded inserts. So, like as far as the form factor goes, this actually almost seems okay. Anyway, it is very interesting that it's a single AAA. like, yeah, it's got to have a boost converter to get this thing working. But there you go. There's our EF detection, and it's got the milliamps, beeps, rotational. No, you can get it to a point where it doesn't work at all because the ground is in between there. So, you know, not the best, but it does have visual as well as audible. And it's beeping at me just picking up, just touching the probes and doing stuff. Yeah. Okay, so I'm going to push our function button there. Continuity tester. There. No. You know, oh, visual as well. Oh, you know, look, oh God, I'm not going to review this thing, but yeah, I don't know. It might have to get a grudging pass on this for its form factor. Like if you're, you know, really set on these form factors, the non-contact tester might come in handy or something. But you know, like I've done a review on pocket multimeters, and there's better ones out there. So. Ugh. Germany again. What is that third suck of the Sav? Hi Dave, I got a digital test something. It's from an in-circuit test system. Thank you from AAAAA. That's all they got their name as. So let's have a squeeze. Oh, okay. Looks like, that's interesting. Ceramic hybrid jobby. There it is, a ceramic hybrid, and I used to work at GC Marconi at Meadowbank here in Sydney, and they actually had their own ceramic hybrid manufacturing facility. And anyway, I don't know, like it's torn down. It's like the whole place is gone now. It's just some stupid residential complex now. Anyway, they do have, like, I think there's a lane called Faraday Lane or something, and that's like the only thing left of it. Anyway, that was quite sad. But yeah, the reason you use ceramic hybrids is so that you can mix like, you know, ceramic hybrid technology, including like resistors and capacitors and stuff onto the ceramic substrate, and there's various advantages to that, which, you know, at the real high end, that's why they use ceramic hybrid resistor divider networks, for example, in like your real high-end 7.5, 8.5 digit meters and stuff like that. Well, actually, not just the high-end meters. My new BM786 multimeter, it's got a ceramic hybrid resistor divider in it. It just gives better temperature coefficient, more even, you know, everything else. You can match them better. But yeah, typically, the only reason you do it is you wouldn't just solder regular components onto a ceramic substrate board like this. There's almost practically no real advantage to doing that over, like, you know, a fiberglass board. But where it comes in, as you can see, looks like they have combined some little itty bitty teeny weeny ceramic resistor networks, but it almost seems like you wouldn't go to the trouble. Why would you not just use regular off-the-shelf parts in a fiberglass board? I don't know. So I don't know, maybe there's some sort of like thermal performance reason for it, but anyway, you can see down below there, have they done some trims? It almost seems like a waste, but anyway, if anyone has any idea what this puppy's doing, it's a, yeah, just a mix of hybrid technology. You know, there's maybe some thermal performance reasons they're doing it, something like that. What it is, I don't know, is that a H-bridge? If you get right in there, you can actually see the laser trim marks on those components. So if we got some caps and some resistors in there, and they're just laser trim those out, you can see the Ernie Bernie marks in there on them. So yeah, they've trimmed them out, but you know, I don't see like any big massive arrays or anything like that. Okay, they've individually trimmed them, and maybe that's like probably the reason that they've gone to ceramic hybrid technology, to be able to like trim these circuits. It's probably a critical aspect of it, and they decided laser trimming on a ceramic hybrid is better than select on test parts or sort of laser trimming parts in some other way after the fact. So there's a reason behind it, but yep, let us know in the comments down below if you know exactly what's going on with this bad boy. I'm sure you could get some part numbers and maybe do some sort of reverse engineering on that. Hi to all my viewers in New Zealand. I won't do the sound effect. This is from MagicDAQ Geez, I wonder what it is. MagicDAQ.com. Can't possibly guess what this could be. Not that I have any idea what a MagicDAQ is, but, you know, usually your name's a giveaway. It's a multiple thing. We have a acrylic cut things, or, you know, all the rage these days. All the kiddies are doing it. Geez, that's a fairly hefty feeling USB cord. Good old pin header. Thermocouples. We have extensive documentation by the look of it. It's thick as, bro. It's the MagicDAQ. There it is. Got some proper relays on there. None of that solid state rubbish. Hang on, that's just the interface. That is your MagicDAQ. And I don't mind these plug packs. You've seen them. Like, it saves like inventory and stuff like that when you're manufacturing around the world. You just supply the required adapter. I hate it when companies like supply all the adapters, even though they're only going for the one market. And you just snap it in like that, and you got yourself your plug pack suitable for your intended market. Rather like them. So Sean is the CEO at MagicDAQ. Hi Dave, I found I was wasting a lot of time constructing custom test fixtures for development and end-of-line test purposes. Yeah, been there, done that. So I created a generic test module that contains all of the commonly used features. I also developed a super easy to use Python API for a 14-bit USB DAQ to pair with the module. There you go. So, you know, API, you can do all sorts of scripting and interfacing. It's got a test module, plus minus 5 amps, low current measurement into the microamps, switch-in relays and stuff like that. That's the board and main board that we saw. Static power output, variable power output voltages, you know, to power sensors and whatnot. Voltage measurement, plus minus 10 volts input, digital I/O, analog output, PWM and sine wave pulse counter, and there you go. For battery life testing, yes, you could certainly use it for that. Battery charge, discharge, and all that sort of stuff. But of course, you know, you've got to write your own scripts. I don't know what ones he actually provides, but basically end-of-line test fixtures. Yeah, I built test fixtures that look pretty much like that, custom built for holding down boards and probing them and testing them and automating them and stuff like that. So Sean at MagicDAQ, he is offering discounts so for EEVblog fans, so go check it out along with educational discounts. So here's the board that we're actually looking at, 1.1. I like the logo with the magic hat with the traces coming out of it. That's pretty groovy. So yeah, I can see having one of these handy to do production tests. Yep, could have used this over the years for sure. Okay, so the current sensing is designed for various resistor current shunts. They even give you the part numbers. Fantastic. So yeah, you just hook those to your circuit under test, and then you can use the MagicDAQ to measure it. Low current measurement, plus minus 100 microamps, 25 nanoamps resolution by the looks of it. Yep. It's all just, you know, basic current shunt stuff and things like that. Geez, this is all pretty comprehensive documentation. I'm liking this. Measurement resolution, all sorts of stuff. Anyway, yeah, we won't go to town. Provides the mechanical interface as well, which is very nice. And then you've got the USB DAQ thing itself, which we'll take a look at. Benchtop automation testing. Has it got, I assume, like you can do, you know, it's got trigger capability and stuff like that, but it looks like it's all, I don't think there's like a general purpose off-the-shelf app. The idea is that, you know, it's like you can't just use this off the shelf. You've got to use the API, and it looks like compatible with MagicDAQ off-the-shelf test jig. Is that thing we saw, the physical one we saw before? But so yeah, it doesn't say anything about a general purpose app. It's just Python API type stuff. I have to check out the website, but anyway, there you go. That's a groovy little case. I like this. It comes with a adapter that plugs that in there, so that's rather nice. Oh, that's a DIN rail mount, is it? Looks like it. So yeah, there you go. The DIN rail mount just screws in there like that. I like that. That's neat. And there you go. Got that apart. There's inside the MagicDAQ, and there's not much else to it. There's an ARM, yeah, STM32 micro, and Bob's your uncle. Doesn't look like there's USB isolation though, so yeah, it's all electrically connected. Just be aware of that. If you've got any grounding issues, how not to blow up your oscilloscope video and all that sort of stuff. So yeah, it's an STM micro with a, there you go, there's our ADC interface. I can't actually read that from here. I'm sure you can on the screen. Hang on, I just realized it claims to be an isolated USB DAQ. Sorry, but I'm not seeing any isolation, electrical isolation from the USB there at all. That looks like it probably goes straight in, does it not? I'm not seeing it. Anyway, that's 185 Yankee bucks for the MagicDAQ, plus extra for the additional board if you want that, although, you know, you don't necessarily need that. You can just interface your own stuff and things like that. And yeah, I still don't understand the isolation aspect of it, but anyway, the website looks quite comprehensive with the API interface, and also they will develop like have services to develop custom test jigs and stuff for you and things like that, so they'll work with you. So, you know, it's kind of like a full service kind of thing, so it does seem quite professional. So yeah, I won't have a play around with it in this video, but if that's up your alley, then certainly check out MagicDAQ down below. And of course, like 185 bucks is nothing burger cost when you're setting up custom test jigs and stuff like that. So yeah, to have like all the API interface stuff done for you, yeah, I could have used that over the years.